Good evening, sir.
Good evening, sir.
I'm going to discuss few of the things on probability. This is also one important topic. In the last class, we people have discussed with applications of trigonometry, that is heights and distance.
Yes, sir.
I can go for the probability. Anyone tell me what is the definition of the probability?
Sir,
Sir,
definition of probability is the chances, chance, chance
Can
of
we?
yes, sir. Probability means the chance of an chance of an incident to happen, sir.
So chance of something happening.
Okay.
sir, chance of occurring.
Okay. Chances of occurring. Shashank.
Yes, sir. Chances of anything that we try.
Okay. Chances of anything will occur without knowing any outcome. Correct? So probability is the possibility of occurrence, chances of occurrence, happen something. Yes, as you said, I can write chances of occurrence or happening, what we can write. Okay, right? And after that, when we do one experiment, you will get some outcome, output, right? Suppose if you are tossing a coin, you will get either head or tail. The set of all those outcomes is nothing but a sample space. The next definition is what? It is a sample space. Okay. A sample space is a set of all possible outcomes of an experiment. Set of all possible outcomes of a random experiment. A random experiment. What is meant by random experiment? Doing something without knowing an outcome is called a random experiment. Randomly means without knowing an outcome. If you are doing an experiment, then that experiment is called the random experiment, right? So if I'm taking an example for this sample space, tosses of a coin, tosses of a coin, right? Throwing a die,
Head, tail, head, tail, sir.
throwing a die. I'm taking just one coin, and obviously it is denoted by first letter of the word yes, sample, that is either head or tail. Suppose if I'm rolling a die, the possible outcomes
1 to
are
6, sir. Set of 1 to 6.
set of 1, 2, 3, 4, 5, 6. Right? Suppose if I'm taking two coins, tosses of two coins, tosses of two coins, what happened to this? Two coins means first coin head, second coin is also will give the same head. First coin head, for example, second coin is tail. First coin is tail, second coin is head. First coin tail, second coin is also tail. Suppose if your tosses of a coin, three coins, sample space S is equal to H, all heads, two heads, and you can rotate them. The tail, you can rotate them. Next, two tails, one head. You have to rotate that particular head and all tails. From this, what I can say, guys, when I'm tosses of one coin, when I'm tossing one coin, two outcomes. When I'm tosses of two coins, how many outcomes? Four. Four outcomes. Tosses of three coins, the number of possible outcomes are 8 outcomes. Tosses of n coins, what are the possible outcomes? 2 power n outcomes. For one coin, 2 power 1. For two coins, 2 power 2. For three coins, 2 power 3. For n coins, 2 power n, where n is equal to number of coins or number of trails also. Maximum we can able to write the combinations for 3 coins. If I'm taking 4 coins, how many possible outcomes? Yes, please.
16.
16 outcomes. Very good. 2 power 4. 16 outcomes. Okay. Next, if I'm doing an experiment, with dice, if one die if I'm taking, then possible outcomes are 6 power 1 is equal to 6. Suppose if I'm taking 2 dice, guys. Suppose if I'm taking 2 dice.
12 outcomes, sir.
One die,
6, sir.
6 power 1 is equal to 6 outcomes. 2 dice, 6 square is equal to 36 outcomes. Hope you can understand. And I'll try to write all the combinations, but before going to that, just make a note of all the points what I have written here. I'll wait 1 minute. You can make a note of all the points for coin, for dice. Make it fast.
Sir, what is the questions?
What? Where? I have not given any question.
Sir, if you don't make it fast, I thought you gave some questions, sir.
No. Is it completed?
Done, sir.
Yes, sir.
So I'll try to write the combination of the dice? What are the possibilities when we have the two dice? Can we write 1 1? Next 1 2. Next 1 3, 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Like that, but maximum he will ask for two dice. We can write only possibilities of two dice. For three dice, it is not possible to write the combinations, but I can say that 6 cube is the required possible outcomes. These are the combinations, 36 possible outcomes, what I have given to you. When two dice are rolled, the following possibilities, probabilities are to be used. And for n dice, what I can write? For n dice, 6 power n outcomes. 6 power n outcomes. Hope you can understand, guys, related to the coin and the possible outcomes, the dice and possible outcomes. Now I can have the pack of playing cards. Even I can show the figure, the possibilities of the figure for the pack of playing cards.
50 cards,
Now,
sir.
how many cards are there?
50.
Pack of
52.
playing cards. Pack of playing cards. Nana, this is important topic for 9th and 10th standard. Number of cards are 52. Their colors and the suits are given to you. 26 red, 26 black, and we have total 4 suits: club, diamond, heart, and spade. Their shapes are also given to you. Once you can see the shapes of all the cards.
Yes, sir.
And even I can give the types also. Most of you people are known regarding to this concept. And in pack of playing cards, he'll ask the question, number of questions he'll ask, guys. Please be careful on these shapes as well as color and suits. 4 suits are there. We can call it as a club, diamond, heart, and spade. But we need to have the flow chart of this pack of playing cards. So here 2 to 9, sorry. Here 2 to 10 are the numbers. And the rest of the 4 are 1 king, queen, jack, and ace. As I said, 26 black, 26 red, diamond and heart, spade and club. None of face cards are there. Face cards. What are the face cards? If you are observing king, queen, jack, only 3 face cards are there. King, queen, jack. How many king cards are there in a pack? How many queen cards are there in a pack? How many jack cards are there in a pack? Each of 4. Remember, ace, it is represented by letter A, is not a face card, as I have given a star mark. A cards are not face cards. consider this as number 1. I'm taking this is represented for number 1, and face cards are, total number of face cards are 12, out of which 4 king, 4 queen, 4 jack. So non-face cards are 52 minus 12, it is 40. Whenever he is asking the question related to the number of non-face cards, face cards means king, queen, jack 12. Non-face cards means total 40 non-face cards are there. And this concept will create some problem for us. So try to have a look on a pack of playing cards. This is the third point in this concept. One is a coin. The second one is a dice. The third one is a pack of playing cards. Have a look and try to take the flow chart also.
Sir, can you scroll down?
Sir, once can you scroll up? No, sir. Pack of playing cards, sir. Sir,
Yes.
sir, what is it, sir? 13 heart, sir.
Shape, heart shape. Heart shape. How many cards are there? Heart shape cards 13. If you want, you can count it. Heart shape.
Okay, sir. Okay, sir.
Spade. But it's clear. This flow chart important, Nana. Downside, I have given flow chart. Total cards are 52. Total number of cards are 52. Out of which 26 black and 26 red. And if you are observing that from each suit, 2 to 10 numbers, one is an ace. And rest of the three are king, queen, and jack. King, queen, jack, and ace are fixed cards for all the 4 sets. So from each suit, one king, one queen, one jack, and one ace. 2 to 10. Total 9 plus 4, 13 cards are there in each suit. Is it clear, Nana, related to these 3 concepts? And remember, face cards, non-face cards. Face cards and non-face cards. Can I go for the next point?
Sir, 1 minute, sir.
And this is important even for your future. Suppose if you are opted mathematics or in all competitive examinations till 10th standard. In 10th standard, you have to write one national level examination, that is, we can call it as an NTSC, National Talent Search Examination. So in that syllabus, this takes an important role. This probability takes an important role. All the topics what I have discussed till now will be useful for all the competitive examinations. Probability and statistics is also there. We'll try to continue with statistics also. Make it fast, guys. I need to go for 2-3 points, and
Done.
afterwards we'll go for the problems.
Done.
Very good. So I have discussed with sample space, random experiment, outcomes, output. Next, I'll write one more definition, that is an event. Event. Event means it is something less than the sample space. Something less than the sample space. So in probability or set definition, we can call it as a, which is a subset of the sample space, subset of a sample space. Something less, which is something less or equals to sample space. Sample space. Okay. Now, when we taking a die, for example, if I'm taking a die, you know that the sample space S is equal to, as you said, we can have 1, 2, 3, 4, 5, 6 are the sample space. So we can take event E1 is 2, 4, 6, set of all even numbers. Set of all even numbers. We can take set of all even numbers. If I'm taking E2 is also an event, we can take 2, 3, 5. Set of all
Prime.
prime numbers. Prime numbers. Next, E3, 1, 4. Set of all yes, please. Set of all.
Perfect square, sir.
Very good. Perfect square. Perfect squares. These are all called events. Event means which is something less than your total outcome of the experiment. Right? Now, the number of elements in the given sample space or event can be represented by the next definition, cardinal number. Cardinal number, which acting as a counting machine. Cardinal number means represents the number of elements in the sample space. Represents number of elements in the sample space. Number of elements in the sample space denoted by If I'm taking n bracket s, 6 elements are there. N bracket e2, n bracket e2. N means it is a cardinal number, is equal to 3. N bracket e3 is equal to 2. So which acting as a counting machine, just count it, that how many elements are there, it will count it, will give the result. That is called the cardinal number. Sir, why you are using? That's we are using for finding the probability. For finding the probability. Now, when we are doing one experiment, the set of all possible outcomes, we can call it as favorable outcomes. Total possible outcomes, out of which, suppose if you are asking even numbers, only even numbers, we can call it as a favorable outcomes. Total possible outcomes. These are the total possible outcomes. Total possible outcomes. Suppose he want only even numbers. These are called favorable outcomes. Favorable outcomes. So when we tossing a coin, what is the probability of getting an even number? So when we tossing a coin, all the 6 possibilities are there, out of which we are going to select only even numbers. Only even. Only even numbers means just 2, 4, 6. These are called the favorable numbers, which will be favored to you. And the total number of possible outcomes are 6, out of which favorable only 3. So based upon this favorable and possible total possible outcomes, I can define the probability definition. Hope these two definitions are clear, guys. Event and cardinal number. Make a note of these 2 points. Event and cardinal number.
Sir, subset means less or equal, sir.
Either less than or equal to.
Okay, sir.
Something less, or you can write something less than or equal to. Something less or equal to. Still anyone writing? Make it fast. Yes, please complete it. I'll go for the probability, the definition of the probability. Anyone can define the probability?
Sir, probability is equal to number of favorable conditions by sample space, sir.
Total number of possible outcomes. Suppose E be an event of sample space S then the probability of an event, the probability of an event E is P of E is equal to N of E divided by N of S. So first I'll write number of favorable cases divided by total number of cases. That is N bracket E divided by N bracket S. Completed? I'll give an examples related to this concept. As I said, find the probability of getting an even number find the probability of getting an even number when we take a dice, when we throwing a die or rolling a dice. So what are the possible outcomes? S is equal to 1, 2, 3,
4, 5, 6.
4, 5, 6. From this, N bracket S is equal to 6. Possibility of an event is an even
2,
number
4, 6.
2, 4, 6. The number
3.
of elements in an event
3.
E is equal to 3. So probability of E is equal to, as I said, N bracket E divided by N bracket S. N bracket E means it is 3. N bracket S means it is 6. 3
2,
divided
sir.
by 6 means 1 divided by
1 by 2.
is the required answer. Now, few of the points are going to remember when we have the discussion of this probability concept. We can call it as an axioms of probability, the conditions of probability, axioms or conditions of probability. So what are the conditions of probability? Whenever we are finding the total probability of the sample space, it is always equal to 1. The probability of the sample space is always equal to 1. Axioms of probability, what we can call. And the probability of any event lies between 0 to 1. Let us observe the given question. 1 by 2 means it is a 0.5. The probability of any event lies between 0 to 1 only. Next, probability of the success plus probability of the failure, and failure is denoted by E dash, always equal to 1. Suppose if I am taking a coin, when we taking a coin, we can have H and T. What is the probability of head? Only one head is there out of the two. What is the probability of T? Tail means H dash. We can take other than H. Only one tail is there out of the two. If I'm adding these two, probability of the sample space, that is H and H dash. That is probability of head plus probability of tail. Tail means it is, we can call it as H dash also, is equal to 1 by 2 plus 1 by 2. It should be how much? 2 divided by 2. Your answer is 1. That is the third point. Even if you want, you can write, you can deduce from this is as P of E dash is equal to 1 minus P of E. P of E is equal to 1 minus P of E dash. So these are the three axioms of the probabilities are going to remember. Hope today's concept is clear, guys. What are the points? The definition I have given to you. Coin, related to coin that I have discussed. The sample space event. Dice, pack of playing cards. And the cardinal number probability definition. That's it for today, guys. Today concept is the probability I have started, and tomorrow we'll try to discuss few of the solved examples from this concept. That's it for today. We'll continue tomorrow.
Bye, sir.
Bye. Good night, guys. Good night to all of you. We'll meet again tomorrow.
Thank you, sir. Thank you, sir. Bye, sir. Good night, sir.